determine the constant A so that the vector field F 2x plus 3y I cap plus 3y minus 2z j cap plus y plus az k cap is solenoidal. So this term solenoidal is very important. So what is the condition for a vector to be solenoidal? The condition is divergence of this vector field F should be 0. So this is the condition for solenoidal field. So if I calculate the vector or the force given here, and the divergence if I equate to 0, and then with that condition I can determine or calculate the value A. So here the A is y plus az. This A I'm talking about, we have to calculate. So let us start calculating the value or the divergence F equal to 0. So divergence, this operator, can be written as I del x plus j del y plus k del z. So divergence of F is equal to I del x plus j del y plus k del z dot the vector 2x plus 3y I cap plus 3y minus 2z j cap plus y plus az k cap. So we know that for a dot product, to calculate the divergence, and this value I should equate to 0. So this is the condition. So while calculating this divergence, keep in mind that I dot I, if you remember in class 11, when you have this dot product, so I dot I always gives I dot I gives 1, and j dot j gives 1, k dot k gives 1. But I dot j or j dot k or I dot k, when these vectors are perpendicular, two unit vectors, the dot product of these two vectors which are perpendicular should be 0. Because they are same vectors, they are in the same direction, so we have their dot product to be 1. Because if you have this definition of dot product, we have cos 0 because they are in the same line or same vector, cos 0, which means 1, we get the dot product as 1. This is from your class 11 concept. So when I have this I dot I can write down this one and this one, then j dot j, and then k dot k. So these three terms, I mean first term with the first term, second term with the second term, they will undergo, and the rest dot product becomes 0. So I will not consider those. So I dot I, so I have del x of, so when I multiply I dot product, I get 1. So I have the remaining term as del x, 2x plus 3y. Then I have del y, 3y minus 2z. Then I have del z, y plus az. And this value I should equate to 0. So first I have to calculate this del x of 2x plus 3y. So that's the partial derivative. So when I do this, remember that this derivative of x will occur. The rest terms except x all are taken to be constant. So when I do the derivative of 2x plus 3y with respect to x, I have 2. When I do the derivative of y, it's 3y minus 2z with respect to y, that is del y, I have plus 3. And del z, when I do del z of y plus az, I have the result as a. And this value, divergence of f, should be 0 for solenoid. So I have 5 plus a equal to 0 or a equal to minus 5. So that's the value of a which is to be determined. We move to another problem. Evaluate divergence of r vector by r cube. So when I write r cube, I don't put an arrow on this, which means that this is not a vector. This is magnitude of the vector r with a power 3, that means r cube. So what should be my first step? I write this expression in this fashion: divergence of vector r multiplied by r to the power of minus 3. Please remember, this r to the power of minus 3 is the magnitude of r, and when I have an arrow on r, which means it represents a vector r. So I have to find out this value. I can also write down in this way: divergence of r minus 3 or r. It means the same. Okay. Now what is the vector r? The vector r is x I cap, y j cap, z k cap. And what is the magnitude of r? I don't write the vector sign, so I have only r, and it is root over x square plus y square plus z square. So I can write down x square plus y square plus z square. Instead of writing root, I write to the power of half. Okay. So first, to evaluate or to find out the value of divergence r to the power of minus 3 with multiplied by r vector, I will use an identity. So I use the identity divergence. So remember, this r to the power of minus 3, this one is a scalar quantity, and r vector, this is a vector quantity. Okay. So I have, let's see, I have this vector, sorry, I have this vector r to the power of minus 3. That is not a vector, that is a scalar. So I will use the identity divergence of phi vector a. So here phi is a scalar. Here r to the power of minus 3 is a scalar and a is a vector. Here r is a vector. So this identity leads to phi equal to phi divergence of vector a plus grad phi divergence or dot vector a. So if I compare this identity with my given problem, here phi is r to the power of minus 3 and vector A is your r vector. So if I use this identity, how should I write then? I can write this divergence of vector r into r to the power of minus 3 as, I use this identity, phi, which is r to the power of minus 3, bracket, divergence of vector r plus grad of scalar, that is minus 3, r to the power of minus 3 dot vector r. Okay? Now, we have another identity which is given as grad of r to the power of n is equal to n r to the power of n minus 2 r vector. So when you have grad, see, remember, when you have grad, there is no dot sign here. Grad of r to the power of n. So r to the power of n is a scalar quantity. So grad of phi, this is an important identity, gives n to the power of r to the power of n minus 2 multiplied by vector r. So remember, I have in this second bracket grad r to the power of minus 3. And also I will use another identity which is also very important and already discussed in class, that divergence of r, this value is 3. This can be proved by calculating the divergence of vector r. This is easy. You can use, we have done it in the class several times. So divergence of r equal to 3, that you have to remember. We can also do it to calculate the value of divergence r, but you can directly use the value 3. So divergence of r is taken as 3, and I will use this identity grad to the power of r to the power of n equal to n r to the power of n minus 2 vector r. I will use this identity here. So what I have, r to the power of minus 3, divergence of r is 3, the value here, plus I use this identity, I have minus 3 r to the power of minus 5 r vector dot bracket outside r dot r. So when this r goes outside the bracket, it becomes r dot r, which is r square. So I can write 3 r to the power of minus 3 minus 3 r to the power of minus 5 and r dot r. This r goes outside and becomes r dot r. So 3 r to the power of minus 3 minus 3 r to the power of minus 5 and r dot r becomes r square. So finally I have 3 r to the power of minus 3 minus 3 r to the power of minus 3 and the value is 0. Okay. So we are asked to calculate divergence of vector r divided by r to the power of 3. So the vector r is given, or you have to consider as xi cap, yj cap plus zk cap, and the magnitude is root over x square plus y square plus z square. We will use the identity divergence of phi a, where phi is scalar and a is vector. We use that identity there to break this term. And then we use another identity, grad of r to the power of n equal to n r to the power of n minus 2 r vector. And we have the third important findings, that is divergence of r3. This problem or the proof has been discussed many times in class. So here I am directly taking the value divergence of r equal to 3. Substituting this value here, I finally get 0. So these two questions are very important from the chapter vector. All the best. Thank you so much.